So we have some of our speakers moderated by John. I will let you then introduce all the speakers that are here today. And so the panel is themed about the future of Scala, which is kind of a hot topic today, as you know, with Scala 3 incoming in the next years. We'll see. So I'll let the microphone to John, and you can pass it around as you wish and moderate.
Give Olaf the microphone, because I'm going to introduce him first.
Hello.
So, welcome, Olaf. This is Olaf Pock-Gersen.
Good.
From the Scala Center. Was my pronunciation adequate?
Pot was good.
Pot. Yeah. It's always a challenge. So Olaf works on a lot of different tools for Scala.
That's true.
And you are living most of the time in Switzerland.
Yep.
Working at the Scala Center. I will do very brief introductions to everybody first, and then I've got a few questions. So please, first of all, welcome Olaf. And that was quite a rousing applause. I hope everybody gets an equally large one. To my right is Mirko Dotter. Welcome.
Ciao a tutti.
And Mirko, you have developed with Julian Dragos Hydra, which is a faster Scala compiler.
That's right.
At triple quote.
Yes, indeed.
Good. And you're also living in Lausanne.
Mm-hmm. It's quite a nice place.
It's quite a nice place. It is. I've been many times. In fact, you gave him his round of applause before he spoke. So I'm all out of sync now. But so to my left is Heather Miller.
Thank you. It's just like, let's see how loud we can get it, like, as it goes onward. Like, we can get louder and louder. Yeah.
And Heather is the fourth, if you include myself, the fourth person on this panel who has at some point lived in Lausanne.
It's like, who else hasn't lived in Lausanne? I mean, isn't most people? What?
So Heather has worked for the last 2.5 years at the Scala Center as executive director, and has now departed for greener pastures in Pittsburgh.
It's very green there, actually. Like, extremely green, literally.
Fewer lakes, fewer mountains, more
green.
More green. And before that, you were a PhD student under Martin Adersky. As were you?
No, I didn't do a PhD.
Ah, okay.
Yeah.
They stopped at
I'm not a doctor.
Yeah, you're a master's. So we've. So I think we need some more diversity on this panel. Miles has not studied under Martin.
No, I haven't.
You have not.
No, until.
He just looks like he's got
not
a PhD.
computer science either.
But he's going to be in Lausanne.
But you haven't yet lived in Lausanne. But
I haven't. I'm not going to.
You're not planning to.
No.
We'll talk about that later. But this is Miles Sabin, in case you hadn't already worked it out. Creator and maintainer of Shapeless and numerous type-level additions to the Scala compiler in the past, present, and future, I imagine. And to Miles's left...
Hello.
This is Luca Jacobo. And Luca is a... I can't get over this. We have Scala days and we do these panels with probably 1,000 people in the room. And it's just like this little applause. This is wonderful. This is the Italian spirit. I'm very pleased. Luca is a software engineer at CodeCentric in Dusseldorf. And you are a prolific contributor to the type-level ecosystem, particularly CATS.
Cats effect, cats MTL, cats taggers.
Yeah, I already said prolific. You did. they get it. And also a frequent conference speaker.
Yeah.
No, the last
And-
2 years at least.
Yeah, and a friendly face if you ever venture into the many of the type level Gitter channels.
Definitely, yeah.
So this is our panel, and let's have another round of applause for the whole panel. Seeing as you're so good. Now, I have a few prepared questions for the panel. These are the things which I think may... I've got a mic here, they can hear
You
me.
can hand it to whoever needs it.
Oh, okay, so I decide who speaks
Yeah.
next. Okay,
That's what I'm
fine, okay. So I'm actually going to start with a question for Miles, so that goes back. It could have remained. So, Miles, I think I tweeted this recently, but you, I think maybe 3 or 4 years ago, you were one of the greatest skeptics of Scala 3, Dotty. It was announced at a conference by Martin in conjunction with the dot calculus. The big announcement was that it had union types. And I think at the time you were just a little bit unexcited by it. Now we're 3 years down the line. We've had more announcements of more features, and you've sort of made a transition over that period, as far as I can see, to being a little bit of a skeptic to one of the greatest enthusiasts, to the point where earlier this week you announced that you'll be working directly with Martin at EPFL, but not in Lausanne, on some type level enhancements for the Scala 3 compiler. So over those 3 years, can you tell the audience a little bit about if there are any key moments where you started to change your mind, or you started to see evidence that it was more than just Scala 2 plus union types?
Yeah. No, I think the way you characterised my initial reaction to the first outing of Dotty, I think it was at Strange Loop. Exactly when? 2013, maybe?
The trouble with types was the name of the
Yeah, something like that.
I think you went to ICFP straight afterwards, and
Yes, that's exactly it. I think it was a very, for me, it was quite a strange talk. Martin was presenting Dotty. It kind of felt like the things that he was adding over and above Scala 2 at that point were not enough to get excited about, and certainly, presenting to the audience at Strange Loop, who are, I guess, sort of PL theory curious group of people. It's a sort of semi-industry, semi-vaguely, academic fanfic kind of conference. I think self-described in that way as well, pretty much. So I'm not being particularly rude. And I think there was a certain amount of perplexity about what was actually being proposed and what was being offered over and above what Scala already had. I went straight. I was presenting there sort of a joint talk with Edwin Brady of Idris on sort of dependent types in Scala, dependent types in Idris. And it kind of felt to me, going from there straight on to ICFP, that the future is dependent types. I still very much think that's the case, and that the sort of the direction we were being shown for Dotty at the time was kind of not really cutting with either the grain of what industry was interested in, or with the grain of what academia are still doing. And I was kind of worried about that, because I kind of felt that really you need to have at least one, ideally both, of those constituencies kind of interested in what you're doing, just to simply get the right level of interest, both in terms of practitioners actually wanting this stuff and pushing for it and wanting to do interesting things with it, and also you need to be able to kind of hook into the large body of academic research work that's being done that can inform this kind of stuff, because LAMP, EPFL are great, but it is one relatively small group. There is a very, very large community of researchers working in this kind of area, and it's important to be able to.
Do you think the dot calculus?
I think the dot calculus work, I think, is fantastic.
By virtue of being a sound foundation upon which the language.
I think it's very, very useful. It's very, very interesting. I've always been super keen on that stuff. So I guess it kind of felt like there's a sort of reworking of some of the underpinnings with some very, very minor little sort of additional features sort of sprinkled on top, which weren't really enough to excite anybody. And I don't know. I was anxious about the future at that point. I think since then, and particularly I think really in the last couple of years, I've got a sense for I suppose a number of things. One of them, I think the sort of ambitions for what's being offered to programmers on the surface has grown significantly, to the extent that I think that the gains are definitely beginning to, for me at least, to look like they outweigh the pains of transition, which will be significant. Having said that, I think something that I think we've all become aware of. Perhaps it should have been more obvious more sooner. But the DOTI compiler can consume current Scala 2 binaries, and this is a very big deal, because it means that people can start using DOTI without having to completely cut themselves adrift from the entire ecosystem of open source Scala 2 binary artifacts, which, as Heather in her talk this morning said, is one of the key drivers of adoption of programming languages, like the availability of good high quality open source projects.
And so, what you said is true at the moment, and in the future, Scala 2 will be able to consume DOTI by virtue of Tasty.
Yeah, absolutely. This is looking very promising. So what's on offer, I think, has got better. What the costs are, I think the costs have gone down. And I think some really good decisions are being made about some of the more problematic and fraught aspects of Scala 2. I have derived enormous value from Scala 2 macros over the last few years in Shapeless, but I think that we will look back on them with retrospect and I think decide that actually they were taking us down the wrong path, that a great many of our current transition worries and ability to evolve the current Scala 2 compiler in its current form have actually been we can actually put those down to the way that macros were incorporated in Scala 2, and I think what Martin is proposing, it's changing rapidly even as we speak, but as the replacement for that is looking very, very promising, and I'm very encouraged by that.
Good. And I was actually going to ask you for some specific examples, but you've spoken long enough. So I'm going to ask you to hand the microphone to Luca, because one of the things Martin promised a couple of months ago in Scala 3 was first-class type class support. Type classes have become popular probably more over the last 5 years than the first 5 years of Scala's existence by virtue of sort of progressive improvements like context bounds, but they've never had first-class support in the language. Now, Martin made a proposal that received a lot of debate and a lot of discussion, some of it some a little bit fraught with disagreement. And then more recently, Luca put his head on the line and made his own proposal. Can you tell the audience what sort of issues you were trying to fix with Martin's proposal that yours does better or attempts to do better?
Right. So first of all, if we look at Martin's proposal, I think it does a lot of things very well. And of course, there's a lot of things that I think we could sort of like iterate on. But what my proposal does a bit differently is that it looks at the way type classes are used today and every day for a lot of the FP-centric programmers, so a lot of the guys in the type level ecosystem. And I think it's of course important because a type class proposal should essentially not just cater to well, more standard OP, but also of course to, I'm going to say us, but I actually mean all FP-centric developers. So in essence, what I'm trying to say is that that Martin's proposal was very great, but there were some problems with regards to multi-parameter type classes. In Cat's Effect, for example, we make very heavy usage of multi-parameter type classes, and that is I think one of the biggest. Well, I wouldn't want to say flaws. But one of the
Could you say the same thing about context bounds? They solve single parameter.
yeah,
type
yeah,
classes, but-
it's very yeah,
Yeah.
that's true. Yeah, and context bounds are great, and they're a lot nicer on the eye. But there's no real solution yet for multi-parameter type classes. You can do it
there
with
is.
kind project.
Dotty has it implemented already. So on the right-hand side of a context bound, you can put a type lambda.
Right, yeah, that's what you can do today
yeah.
with kind projector as well.
Right.
And that works, but it needs some getting used to. But I think like once people are more used to that, I think it's fine. And I know a lot of people that use it. But what's I think at the heart of a lot of the criticism is that Martin's proposal supports some kind of notion of local coherence, where there's a very famous problem for the more FP-centric developers that if you have type classes that both, or for a number of type classes that extend from some kind of base type class, then if you try to use them together, you get an ambiguous implicit error. And Martin's proposal solved that issue in a way that requires some relatively large amount of boilerplate, which
So you've proposed a more general solution that works in all
Right.
circumstances.
and I think my proposal is very utopian. I don't think it's ever going
Yeah.
to make it into the compiler, which is
Well,
fully
don't
fine.
be too defeatist, because I think there's
No.
a chance that we could certainly iterate on what you've done, and it could I think already be a better proposal than Martin's, even if the final thing is
Sure.
is a little bit
So
different from what we've got now.
what I really wanted to achieve with the proposal is not to have like a specific implementation in mind, but what I really wanted to talk about is the features that a lot of the FP developers use every day, and that we would like to see in some kind of proposal. And what I did with that type class proposal is to just have like an idea of how that could look. And I'm totally open to any kind of different proposal that takes in mind all of these features that we actually liked, and that is a kind of coherent system where you don't have these implicit ambiguities and support for multi-parameter type classes.
So I think there's a lot of hope that we'll now end up somewhere with better syntax, less boilerplate, and happier functional programmers.
Yeah, exactly. So, yeah, right now we have like at least 4 different type class encodings used throughout the like more experimental parts.
I mean, it's one of the most common patterns you ever see in Scala
Exactly,
code.
yeah.
And I think we call it a pattern because you do have to follow.
You do have to follow
a sort of routine of.
And of course, there's simulacrum, which helps a lot, but simulacrum again doesn't work for multi-parameter type classes.
Okay,
And
enough about type classes.
Okay,
Because I could let you keep talking, and you would have plenty to say.
yeah,
But the audience will probably get tired of type classes, and they'll start using things like inheritance instead, which would be a disastrous outcome.
inheritance. Yeah.
So let's talk about something a little bit different. I'm going to ask Mirko a question now. Now you're working on a new compiler, or a would you call it a fork of the Scala compiler?
That's right.
Fork is the word you use.
Yeah, it's a fork of the Scala compiler.
And that's the Scala 2 compiler, which currently has tens of thousands of users.
Mm-hmm.
And of these many tens of thousands of users, many are, or some of whom are here today, a lot of them aren't happy about the compile times. And the problem that Hydra is solving is to reduce the compile time, reduce developer frustration, to tighten each iteration of developing and compiling and testing and then running, so that the developers are remain focused.
Right.
They don't get distracted. They don't go off and make coffee. They stay in a state of flow.
No sword fighting.
Yes,
That's right.
Exactly. If you've seen the cartoon, and you must have been very happy to see that Dotty is just as slow as Scala C. Because that opportunity will remain remain there in the future. Is that something you're thinking about already?
I was not thinking about that.
I mean, it's just an idea. You're welcome to take the idea and run with it.
No, let's put it this way. We're definitely following on what's happening on Dotty, but we have not been doing anything related to Dotty at the moment. So our focus it's entirely on Scala 2.11 and 2.12, and basically all stable releases that are used by the enterprise. At the end of the day, what we heard, so me and Julian have been working on Lightband before it was type-safe, and this idea of creating triple quote, it didn't born out of nothing. It was actually by talking to customers of TypeSafe at the time that they were often complaining about compilation times. So the problem is usually not very apparent in, I would say, in the open source community because you tend to have small projects. And so, well, maybe in the worst case, your compile times are maybe a couple of minutes or something like that, which is still not ideal, but it's manageable.
It's still enough to break the flow.
I completely agree, but when you hear from customers that it takes maybe 30 minutes, 40 minutes, an hour.
What's the longest you've heard?
It's about an hour.
About an hour. So
yeah.
People are making a small change, they compile, they wait an hour, and then they find that the change didn't actually fix anything.
Right. And, I can tell you that actually this is a story that happened a month ago with a customer of ours. They had compile times of 20 minutes, and we actually had a chance to look at their code base and understand why, where was the compiling spending those 20 minutes. And, well, thanks to Hydra and some optimization that we built on top of Hydra, now it's taking 3 minutes and a half. So they got 6x.
6x.
Right.
For a large project, and I guess the gains wouldn't be quite so much for a smaller project.
It kind of depends. I mean, it's hard to give you like.
I guess
there
it depends a lot
receipt.
on the structure of the project and the links between different parts.
Exactly. It depends a lot of the kind of project you have and whether. We have also seen projects where 80-90% of compilation time is just spent on one single file. Like I've seen recently, Slake table generated. Slake source file that was generated by with just tables, a tables definition on it, and it was taking 90% of the total compilation time. And in that case, unfortunately at the moment there is not much we can do because Hydra parallelize at the level of source files. So if you have one file that takes 90%, then you can't beat that. Basically, the best you can get is actually compile times that are 90% of what you had.
But the customer could split that file up eventually themselves.
That's usually what we tell people is that by splitting it up, well, then you actually give a chance to Hydra to work better. And that also has benefits if you're using SBT and just vanilla Scala compiler. By splitting up the file, you're actually getting usually better incremental compile times just because, you might not have to recompile all of the source file that you had before just because you'd be splitting up things. So these have benefits.
So the solution for many people with slow to compile projects is a combination of the Hydra compiler and also some good advice on how to structure the project.
Yeah, absolutely.
And do you at Triple Croak provide both? Do you provide both the product being Hydra and the service of consulting?
Right, that's correct. If anyone has, let's say, a need for getting better build times, so basically lowering their build times and understanding where, the reason behind the long compilation times, we can definitely help both from a services perspective and with the product. But to get back about the Dotty question.
Yeah.
So yes, Dotty is definitely an opportunity, as you put it. Apparently, it's not faster than Scala C.
But it's to be fair to Dotty, it's not slower either.
Right. No, it looks like it's about the same. And
I think also it's probably fair to say that at the time Dotty was announced, the people were talking about it being sort of 2 times faster than Scala C. That was the expectation, and it probably is 2 times faster than the Scala C that was being used 3 or 4 years ago.
That's right.
But progressive improvements by Lightbend have actually made Scala C faster. Not really a massive step change, except maybe when we went to the Java 8 backend, but
Well, I
It's
actually
been
think that
progressive
between
over-
2.12.0 and 2.12.4, you get about
okay.
20% speed up
20%,
with
I mean,
Vanilla
that's-
Scala.
yeah.
And that was thanks to the work that the Lightband team has done.
Yeah.
So it's also true that I believe 2.12.0 was actually slower than 2.11 something.
There was an issue
So-
there at some point.
it's all on perspective. But anyway, no, I think they actually make great work, and they're keeping doing great work. Performance it's very much an important. Well, it's a really important point now for the Lightband Scala team. They have ways to actually track performances of the Scala compiler, and so they can know whenever they have a regression, they can actually look at the commit and then understand and basically get back to the previous performances, which is extremely important.
So I think that, seeing as this is a panel on the future of Scala, I think the future of Scala will mean faster compile times, one way or another.
Absolutely, I certainly believe that we can make Scala compilation as fast as Java. Of course, it's gonna require work, but with the current hardware and the fact that we're gonna have more and more cores available, let's use those
So
cores.
parallelism will be one of the solutions, better parallelism.
Right. And also I hear that on the tooling side, there is a lot of work going there to actually reduce some of the overhead that we currently have when we use SPT or Bloop. So there are definitely, there are so many smart people actually working on these problems that I do think there are a lot that we can gain, and the future definitely looks bright from this perspective.
Okay, thank you. If you just pass the mic to your right, I'm going to ask Olaf a question. I can't remember what my question was, though. But while I'm working it out, Olaf maintains at least 4 projects. There were 4 projects I listed here. So Scala Fix, Scala Meta, Scala Format, and the odd one out, Metals.
Explain what those are.
Maybe Olaf can explain what these projects are. And have I missed any?
No.
So he has to his name a mere 4 significant, very useful projects that he maintains.
So I got involved with Meta, Scala Meta, when I approached Eugene Brumaco, who was at the time a PhD student in Martin's lab in Lausanne. I was a master student. So Scala Meta is a library that allows you to parse source code, traverse, find interesting patterns, and transform it and print it. So I got involved because I wanted to create a code formatter. So that's how Scala Format came to be. And then I joined the center to work on Scala Fix, which was people were like, that looks similar to code formatting. You're just fix the code instead of formatting it. And then over this period, we built a lot of very cool foundational work, I think, that I was presenting this morning in the workshop. And about a year ago, I was talking with Gabriele, who is organizing the conference, and we suddenly started to writing a language server using all of this stuff.
And this was Metals.
So, which ended up being Metals, yeah. So the name Meta language server, Metals.
That's clever. And I think, shout if you disagree, but I think Scala's tooling has historically been behind that of many other languages. We've always been playing catch up. Does anyone disagree with that? Yeah, Andrea, you think? Okay, so there are some examples, but I think in terms of IDE support, we are always a little bit behind. You disagree? Okay.
I think it's just the comparison with Java. So
I think so. Java is ahead. We are at parity with. Yeah. Okay.
Yeah.
I think it's Java and C#.
Okay, so there is
They're just
some
great when it
disagreement.
comes to tooling.
C# is amazing, Java is amazing, and I guess more people are writing
Yeah.
JavaScript and TypeScript.
Right. So, but I think a lot of the tooling. I think that the tooling has made great steps in the last year, maybe the last 2 years. It has. I said it's been playing catch up, but it has been as well catching up.
I think in terms of deliverables for someone just starting to write Scala today, there hasn't been much change.
But do you not think that?
I mean, the most impactful work is what the IntelliJ Scala team is doing, especially the latest release.
Do you not think that 3 years ago, a lot of people were using the Scala IDE based on Eclipse, which had a number of issues that were just very difficult for. I mean, you worked on it, Mirko. It was very difficult to solve some of those problems, and the user experience these days is much nicer than it was 3 years ago, 5 years ago.
I'd say, but what has really been impactful, in my opinion, I think, is IntelliJ Scala has gotten significantly better. It's particularly the last release gives you insights on implicits, whether they're ambiguous or missing, and it's phenomenal. If you haven't tried it, it's really, really great. And then I think Eugenia Coda has done some very nice work to simplify, make SPT more approachable. So there's been a lot of impactful work around that, yeah.
Do you think that there's a risk with Dotty about a year or 2 years away that we're going to throw a lot of those advances out and have to restart again? Or do you think that we can transfer a lot of the work that's been done for Scala 2?
I think a lot of the work can be reused. I mean, everything in SPT, IntelliJ Scala, and everything that we're doing with scala-meta and scala-fix will not break with Dotty or Scala 3.
And what does Scala...
Because scala-fix is the way it's designed is that it uses a semantic DB, which is a compiler-agnostic format. We have a very large, nice spec on the data that we need, and to make scala-fix work with Dotty, that would be the equivalent of just producing that data. And this is totally different to how, for example, scala-italy in Eclipse worked, where the tooling was written with the Scala compiler.
But on the Scala sorry, I just wanted to add more information about the semantic DB stuff. I mean, the way I like to think about it is that it's basically like a really nice and easy to query representation of your program. So imagine, you were like a tool and you had to say something intelligent about somebody's code. What would you want to do? Well, you might want to query it. Does anybody use this thing or that thing in this code base? And that's how you should think about this thing called semantic DB. It's really just like some text files, right? But you can think about it as a thing that you can query that is basically a representation of your program without having to run the compiler, which is awesome. Can you imagine all the things that you can do with that if you think about it that way? I mean, it's not just like some esoteric meta-y tool. It's like a thing that you can actually really easily build tools on top of, which is super cool.
And additionally, it's... keep that.
Oh.
Yeah. Additionally, it's... Or maybe Olaf will answer this instead. Yeah, I'll give it to Olaf. And then we'll come back to you. So additionally, semantic DB works quite well with code that doesn't compile as well as code that does compile. Is that right?
Depends on what you need to do.
How well or how badly, yes.
We had great success, I think, in Metals to do navigation on so if you want to go to definition or find references, we were able to make a lot of use of, even in code that wouldn't even tokenize or parse, which was pretty cool.
So it wouldn't even parse, but you can still navigate.
So, which is normally when you're writing code and then suddenly something is broken, but you need to go to definition. We have some really good, but that is, no one can try it out today, but I think we have exciting, promising results.
I mean, it sounds exciting.
Yeah.
Cool. All right, and I've left you until last, Heather, even though you did contribute to that last question.
Sorry.
Oh, no, you're welcome to. In fact, any question that gets asked to the panel, anyone else can try and grab my attention. I can try and bring them in as well. We do only have one microphone apart from my own, though. You've just left the Scala Centre after 2.5 years at the helm.
Yep.
And you've taken it from a non-entity. It didn't exist at the start of 2016, is that right? Or at the mid-2015 it didn't exist.
Yes.
And today it has an advisory board with 8 or so sponsors who are funding the Scala Centre. It has a number of ongoing projects, which most of which have yielded some benefits to the entire community. Over the last 2.5 years, of those projects, of those achievements, which ones are you most proud of?
So I don't want to. I mean, first of all, I guess I'm not like the kind of person to look at the things that we did and then like overly analyze, oh yes, this one makes me the most proud. I guess I'm always just kind of like, oh, what other thing can we fix? Like, where's the things that are fixable, So and also like, a lot of these things are not things that I did. I have nothing to do at all with Scala Meta or Scala Fix or anything like this.
But you
So I'm very proud that they exist, but I did nothing. Like I was just kind of like,
sure,
here, Olaf, have a job, do this thing. You have some ideas. Here,
Well,
so I take zero
is-
credit for that.
Well, that's still an important role, I think. I think in determining the workload of the team, you work with the resources you have.
Well,
sure, but
Olaf
you
works
still-
quite a lot, so also don't like give me compliments on this either. Look at his commits like on the weekends. He's really busy.
Maybe your greatest achievement was in hiring Olaf in that case.
Okay, I'm not sure about.
Or at least
I'm not sure about that interpretation. In any case,
nurturing a team that was able to.
Yes, I'm just very glad that everybody managed to essentially all the projects that we've managed to pick up, we've delivered on. There are a couple of things that have fallen through the cracks, but looking at like the ratio of things that were moderately successful or successful to things that didn't matter or just forgotten about or we dropped, it's like much more in favor of like we did it and it was successful and people seem to be gaining some kind of benefit from that. Even smallish things like the scala-italy profiling tool that Jorge decided was like really good idea. It wasn't only him, obviously. It was actually suggested by the advisory board. He jumped all over it and then like decided he was going to make a little VS Code plugin so you can, that was not even required, but these are even these smallish things where I don't know.
And he wrote the longest ever blog article.
He did, yeah. Yes. I'm not going to stop that, I guess. Perhaps people will find it interesting in some parts of it.
I've got one more follow-up question, but I just want to remind the audience that we will take questions, and if you have something you'd like to ask the panel about the future of Scala, or specifically Dotty and Scala 3, then be ready, because I will. I don't know if we have we do have a roaming microphone in Gabriele's hand. So after the next question, be ready to raise your hand with a question for me. But you're leaving, and Sebastian Deren is taking over. What does Seb bring to the Scala Center?
A ton of technical expertise and knowledge on how to organize and manage and sort of lead open source communities and projects. So he's awesome because he can do technical things as well as people, organizational, sort of social things. And it's kind of hard to find. There's a finite number of people who can do both, right? And I'm really excited because, he's also a very, he's very reasonable. So, he's not like, when it comes to a technical decision or a social decision, he's somebody whom it doesn't matter your viewpoint or how different it is from his. He will listen to it and he will try to understand where you're coming from. And perhaps he will still disagree with you afterwards, but he will listen to you. And he will also, do his best to try to find compromises, which is really nice. Some people can just take very strong opinions and shut other people out and slam doors. You could do that, but he's very reasonable and he's that tendency is super, super valuable, I think, when it comes to trying to make us all happy.
Okay, well, that's something to look forward to. Questions from the audience? Lars has a question. Just here, Gabriele. If you want to ask a particular person, let me know.
Yes, I want to ask Mirko. So you mentioned that Hydra paralyzes on the level of source files. Is that correct? So one thing I've been always wondering. So like Java, Scala has the ability Scala allows a programmer to have cyclic dependencies between source files. And while it's generally, I think, considered to be an anti-pattern to you do that, it still happens frequently because the Scala compiler does not prevent you from doing that. How much easier would your life be as a developer of Hydra if Scala would just flat out reject these cyclic dependencies?
Yeah, it's a really good question. I actually am wondering if how easier it would make our life if that would be the case. But so what I can tell you is that pretty much all code that we see and compiled with Hydra, like it's very often the case that you have a lot of dependencies, interfile dependencies. So whenever one file has to be type checked, in order to type check that file, you also need to type check some other files, just because you might be calling on a method that basically defines the return type of the method you're looking at. So whether not having cyclic references would make an impact on that and would actually speed up compilation, I can't really tell you if it would make a really big difference for parallel compilation. What would definitely make a difference is if we could find a way to reduce these interfile dependencies that actually exist very easily in Scala project just because of implicits, just because of the way you have dependencies that you don't even see, but they exist.
Because you could have two mutually recursive implicits in different files.
Right. Yeah, absolutely. And in that case, you might need to type check information. Like two workers might need to type check information from the other file. So that works out. But on the other hand, there are also optimization that we're working on so that we can reduce this coupling between files so that, if you think about it, you don't end up changing the signatures of your file or of your methods and variables that often. So if you can find a way to be smart, about what you cache and do it properly, then you could massively reduce the dependencies, and so the workers could actually be fairly independent between each other. And as a consequence of that, you can actually get much better benefits when you parallelize, just because you do not need to do much extra work on each work.
So Olaf had something to add.
Right.
If we remove the ability to have cyclic dependencies between files, I think the language would be far less popular. It's actually crazy how it's very difficult to get a refactor code that has cyclic dependencies between files to remove it. I've tried in my own projects. It's really hard. And if you add that as a requirement, almost no code base would compile. And people like cyclic dependencies between files, I think.
You mean they like not having to think about whether there are dependencies?
Yeah, and there are languages that prohibit this, like F# that just have not taken off at the same. And I don't know if that's it, but then another.
I would guess that actually the majority of languages prohibit that in some way or another.
Yeah, it's a compiler writer's dream, but.
Like for example, in C++, it's very hard to have cyclic dependencies between files.
Yeah. But I think on another, there's a lot of work around on parallelizing the compiler, like you guys are doing in Hydra, and the work that Gregor and Eugene Burmako at Twitter have been doing maybe makes it essentially it won't matter because you can very cheaply compute the outlines, which are the public signatures of all files, which is almost for free, and at that point you're independent anyways. Pretty much, you don't have to complete the types.
Okay. Mercury, one last thing to add, and then we'll take another question.
Right. Yeah, there was one thing I wanted to say that actually package objects are one of the worst things to compile. And when it comes to parallelizing compilation in Hydra, that's definitely one thing I'd like to reduce the power of package objects, especially the fact that you can introduce new type in a package object, and the package object itself can refer to it. So those kind of circular references, then those are actually pretty bad, and they do hurt us.
Self-types? Are they?
No, it's not about self-types. It's about introducing.
But I mean, self-types are another opportunity for these sorts of circular dependencies.
Right. Yeah. Absolutely. No. But I was just thinking about package.
Packages are altogether worse than self-types.
Absolutely.
Okay.
At least in our case.
Yeah. All right. Any more questions? Get my attention if you have a question. If nobody has a question, I'm going to ask the panel to ask the panel questions. Have a question over there.
Okay, maybe nobody has an opinion on this. This is I had this kind of feeling that there's a trend toward changing the concurrency primitives towards fibers, whatever fibers means, but generally is like more lightweight processes, not depending on OS processes. But I've seen that kind of usage in both mostly functional programming kind of libraries like Monix or type level task, and now in ZO. And I've also seen proposals to add it to the JVM directly. And this is just a question. Do any of you have kind of figured like this kind of pattern, or have any idea on that?
So does anyone on the panel know anything about fibers, first of all? Miles, would you like to just give, if you can give a brief overview of fibers? I don't know. I hear them mentioned a lot recently.
Well, I can't really speak directly to the current implementation in the work that's being done in the OpenJDK. It's Project Loom, I think. It is a continuation of some work which I did play around with a few years ago, which was kind of interesting. So there was one of the, I think, Lucas Stadler, I think, is the person. He was a PhD student somewhere. He currently works for Oracle Labs, I believe. And his work was on adding continuations to the JVM, and this is quite a few years ago. Very, very interesting work. And I played around with trying to do a comparison between Scala's continuation, sort of language level continuation model, and the JVM level continuation stuff.
So continuations were a feature of Scala available as a plugin around Scala?
They are still a feature of Scala. I mean, it's somewhat neglected these days, but I mean, it's...
So you can still use...
You can still... Yeah, it's a kind of Scala compiler plugin.
But it continues to work in Scala 2.13?
I believe so, yes. It's now a sort of a separate module in the same way that things like Scala XML are.
Do you know of anybody who's using this?
I think it's used quite a lot, actually, sort of secretly squirreled away in various kinds of things.
Right, okay.
So the idea of this stuff, and it's the same with the Loom stuff, is that you can use it to build very lightweight concurrency primitives and things along those lines, or things along that sort. And you know, the advantage is that you don't have quite the same overhead as you do with a full OS level thread. It's kind of pretty clearly a good thing. What's missing, and what has been missing traditionally, has been JVM level support for it. Things like the CPS plugin, I think, did a remarkably good job. I think it was a really fascinating project. I've always kind of rather regretted that it didn't make its way kind of more firmly into the core of Scala.
Well, there's a new Scala compiler that is coming out next year that could potentially...
It could do. I'm not aware of anyone doing any work on that kind of stuff with Dossi.
Do you know anyone who's working on the compiler?
I know one or two people. No, I have other fish to fry.
Right, okay.
Yeah, no, I think the JVM level stuff is very, very interesting. Personally, I'm actually more excited about the fact that the way this stuff actually maps down to the sort of to the JVM is actually promising for us finally getting proper tail calls, which, you know, obviously for the functional programming community on Scala is a really big deal, and that's something that I think it's all part and parcel of the same picture. It's all good news. I think it will inevitably make our life easier building higher level things on top of it. Why are people doing it? I think part of the reason is that by being a non-OS level construct, you end up almost inevitably having a great deal more control over coordination. I mean, essentially it allows you to build. Yeah, exactly. Yeah. Right. Which is intractably difficult, I think, basically with OS level threads typically, and so it's a good thing.
Okay. Thank you, Miles. Does anyone else have anything to add? If not, then I will invite more questions from the audience. Does anyone know how much time we have left? Do I just keep going until someone kicks me off? Or one or two questions, of which 0 have been ventured. We have one at the back.
there is another calendar to take in account, thinking about the future. That is the new release schedule for the JVM. So how this interacts with the new work on scala-3, Dotty, and such.
Who would like to take this question? So, so does anyone think there is any relationship between the JVM release schedule and Dotty Scala-3 that is going to be particularly relevant? Olaf, there we are. Thank you.
Just the thing I saw in the issue tracker, but the JSON SOG in the compiler team follows very closely what's happening on the JDK, which I think is fantastic. And just an example of what in Java 11 they added lines is a method now on string, which returns a stream of strings.
Groundbreaking.
But the standard library in Scala actually has a lines extension method, which returns an iterator, Scala iterator. So there. But this is not like a significant, maybe not what you were hoping for, but. There is work happening in this area to make sure that new additions in the JDK don't break the standard library.
Okay. So yeah, I think maybe not the exciting answer you were hoping for, but Miles, you have something else to add.
Just on that particular thing, that's not the first time this has happened. Was it a method on string quite a few years ago now, I suppose. What was it? It was. I forget which one it was, but anyway, it was a method. There was an extension method provided by the Scala string, and then a method of the same name, but with subtly different semantics arrived on the underlying Java lang string. I completely forget what it was now.
But they had different return types.
Is empty or something? Was it is empty? I can't remember. But I mean. Who? I mean, I really know nothing about this, but it kind of feels to me as though. Tasty is supposed to be helping us out with this kind of thing, I would have thought. No? Is this something which... Does anybody... I mean, who... Mirko, you must know more about this than...
About
no, none of us know anything about Tasty. Heather, do you?
No, I do not. I know a few things that, we'd like to eventually do and use Tasty for, but have they been done? No. So
I suppose if something were compiled with a method that was implemented via an extension method, Tasty would have all of that information. It would be clear to see that the string instance is wrapped by another class, and that would be available to to subsequent compilations, which would be able to identify it, or maybe pattern match on it.
But you'd have to do something knowing that something is different in the JDK still. Like, that's the thing that we're talking about.
But the thing is...
You can use Tasty to help, maybe.
But do you actually even need to know? Because it's still... When that code was compiled and produced the Tasty, it was... the intention of the programmer was to wrap the string and to call the method called the extension method. That should remain correct for all time.
Well...
Yeah.
But the problem is the application point. It's not the definition. The problem is the application point.
But the extension method's applied at the application point. But let's not get too technical on a minor detail that wasn't really the question that was asked.
No, but the question I think is
last point.
The question I think is good though, and
we just don't know the answer.
More seriously, I think some of these new features in Java I'm really excited about. For example, local type inference. I think the more people can enjoy that, I think the world will be a happier place. And then we can finally start talking about more interesting stuff. I mean, fundamentally, Scala introduces a different programming paradigm. So, and then there are a lot of nice additions in the JDK that, I mean, I write Scala in all of my projects, but I still end up using, for example, Java 9.0 file. It's a total quality of life improvement that you can now read a file into a string without doing read all bytes new string with UTF-8 encoding. It sounds silly, but I think I'm very happy to see these the JDK improving and making basic stuff like that more easy.
Okay, so last question. Does anyone have such a thing? Miles, I'll ask you a question again because. Oh, Gabriele, I'll decide whether I want your question or mine. Maybe we will have both. Go on.
Okay, so since we were talking about Tasty, okay. Apparently, I mean, Tasty is a serialization format for Scala trees, which sort of overlaps in solution with semantic DB to some extent.
To some extent.
So this has been asked before in other conferences, but I keep asking this question every 6 months or so, to see whether there's an improvement in that. So how do you, this is probably a question either for anybody who's working on Tasty or for Olaf who's working on semantic DB. How do you see the two collaborating or integrating or sidestepping each other? I don't know.
Yeah.
It's a good question. So what's the intersection or overlap between Tasty and semantic DB? I see them as very complementary. So semantic DB is the face for tooling developers. And the cool thing with semantic DB is that you can build developer tools today for Scala 2. You can write something in an afternoon and people can run it on their code base down to 2.11, which is, there's a lot of Spark code bases out there. And what's appealing is that with Scala 3 coming out and producing Tasty, the way I see the future of the way it goes is that in Scala 2 we have compiler plugins to produce semantic DB, but I think we might be able to produce them directly from the Tasty files. So all of the nice tooling that people have built for Scala 2 will work with Scala 3 without, fingers crossed, with no changes, not even a recompilation. I think that's phenomenal, and that should make us, as Miles was saying, the migration story, it really softens the blow or the migration, that even the tooling that we're writing, refactoring tools, linting tools, just continue to work seamlessly without any issues. And then Tasty itself is still very relevant because it solves a true pain point for the Scala compiler, and you publish a library once. That's the selling point, and it's forwards compatible with new compiler versions. That's quite amazing, I think, and that addresses a different problem than tooling. So Tasty is quite a bit lower level. The way that it persists signatures, it leaks a bit more compiler internals, which is maybe not a great face for a stable API for tooling developers. So my answer is they're complementary, and I think Tasty enables the Dotty team to work really fast on iterating with their ideas today, and they're doing some really nice work also in the LSP space. But semantic DB enables us today to write tools, so no one is blocked, and I think that's good. And I mean, we're in the same corridor. So we eat lunch together, and there is definitely collaboration. So.
Okay, thank you, Olaf. I did have one more question for Miles, which relates to a little bit more detail on what you're expecting to work on in Scala 3, because you mentioned at the very beginning that Scala 2 introduced macros, which were hugely powerful and enabled us to do. I mean, many of your libraries, or Shapeless primarily, has several macros. I've written several macros, and they're a wonderful enabler for things that we couldn't otherwise do. But Scala 3 won't have macros in the same form as Scala 2, but it will have a number of alternative approaches, not just one single approach. So there will be, correct me if I get any of them wrong, we have quotes and splices as one possible metaprogramming paradigm. We have reflect trees. Are they still in? As in some future version of Scala Reflect, and there's transparent methods. Possibly not. Okay, so I'm going to hand you the mic, and I think a lot of this relates to some of the things that will be newly possible in Scala 3 that very much fit into type level programming, which is very much your domain. So if you could just talk about the future of metaprogramming in Scala, that would be a fantastic note, I think, to finish on.
Right, well, I can't really deliver on that question, unfortunately. I mean, I've got some vague ideas about what's going on. Martin has been, and his the people, his students he's working with, have been very, very busily iterating over stuff over the summer. And various things have been tried in various forms, and it's still very much in flux. I played around a bit with transparent methods sort of a few months ago. They look very, very interesting. I think that Martin has decided that perhaps they're not quite the right approach to take. One thing that's dropped out of this, which for me is I think it's something I think I knew all along, but it's very, very interesting to kind of see it very, very explicitly. And that is that certainly the way that I have been using implicit resolution in Shapeless, it's kind of obvious in a way, and certainly I've thought about it in these terms. But it's essentially it's doing pattern matching on types. So you have some set of implicits which are effectively deconstructing and doing structural recursion through types. But there's a whole bunch of stuff associated with implicits which is completely irrelevant to that. So if you look at a typical Shapeless sort of ops type class, it has a couple of instances. Essentially, it has a case for an empty H list, and it has a case for a comms, and that's it. But to resolve that thing at compile time for a large type, you have to do huge amounts of implicit search, which for completely irrelevant types. So all of the implicits which are in scope, and the implicit scope can be really quite large, are things which have to be considered as potential candidates in this pattern match, effectively, which are utterly irrelevant. And in fact, if for whatever reason they ever became relevant, it would almost certainly be a bug of some sort or another. So we kind of have this very, very clear set of implicit methods which correspond to branches of a case. And we really don't want to consider anything else. And it's the search which is the thing that contributes a huge amount to the cost of compiling programs of that form.
Is that just the cost of modularity?
I don't think it is. I think it's
It's
a
not
cost.
an inherent cost. It's
Not. It's the cost of, I think, conflating two different things. One of them is the notion of doing basically a case analysis on types, and the other is the idea of searching for some solution to a problem in a potentially open-ended domain, and they're not the same things. So, for example, Idris, say, has a notion of proof search, which corresponds actually somewhat to implicit resolution and implicit search. But you wouldn't typically, although you can, use that proof search mechanism to do the kinds of things that I do in Shapeless. You would use typical dependently typed programming techniques with this, which are going to correspond more to essentially doing a match on a type of some sort or another. So if we can separate these things out and have some notion of having a pattern match on types, then I think we can get a really interestingly long way. I mean, I don't know yet if what the current state of things are is going to be either necessary or sufficient for what I need to be able to do to make a sort of macro-free Shapeless for Scala 3. But I think there's enough there to be very hopeful, and I think it's close enough to being in the right place that over time we'll be able to get to something.
And your best place to influence it in the right way.
I don't really see how I could be better placed to influence it than that.
Other than being Martin, I suppose. Yes. Short of that, you're doing as well as you can possibly do.
But I mean, my goal absolutely is, and it has been actually all the work that I've been doing with Lightbend on the Scala compiler, is to basically, at a minimum, actually get rid of all the macros in Shapeless. They're horrible, horrible things. Many of the nastiest one is gone. That was the macros associated with lazy, is now largely replaced by biname implicits in 2.13 and in Dotty as well. And the more macros that we can get rid of, the happier I get, because they're just impossible to maintain.
And the more easily tools can reason about the
absolutely.
code.
Yes, indeed.
Tools can't reason about macros without running them generally.
Not at all. I can't reason about macros. So, anyway.
Okay, so I think we're probably ready to finish, unless you had a very important point at the end. But feel free to...
I've lost my thread now. So.
Yeah, I'm sorry. I would like everyone to say thank you to the panel. If you can give them a great roaring cheer, as you did when I introduced them. Come on, let's start. Luka Jakubowicz, Miles Sabin, Heather Miller, Mirko Dotter, and finally Olafur Páll Gerson. Thank you, everyone. And Olaf has a very important announcement.
The most important announcement of today is that there will be Scala stickers on the table over there.
And let's also have a round of applause for John. Thanks for leading it.
Thank you.
So, whoa, we made it. First day. It's almost done. So thank you everyone again. As a reminder, tonight at 9, we're meeting in the Braumeister pub. You find the details and a link to Google Maps on the website. It's like a half an hour walk from here if you're feeling like you're passing through Florence, which is nice. So it's a nice walk to there. So meet us there, bring your badge, and when you get there, find one of us with a blue polos, and we'll give you your complimentary free drinks from our sponsor, Avanscoperta. And I have nothing else to add. See you either tonight or tomorrow.